Okay, I was already talking. So hello everyone again. Nakamute ko no. For today's activity this week, the title of the activity is about the nomenclature of organic compounds. Particularly, we start with hydrocarbons. No? So I'm not sure in the lecture no, if you already started discussing hydrocarbons or nomenclature, but the laboratory will be a supplement to what you are doing in the lecture. So sometimes this one can be nomenclature can be very tedious and it may take time to familiarize really with the nomenclature. So we devoted some activities for the naming of the organic compounds. So some organic compounds are known and easily remembered by their common names. Of course, we know no, that we might not know, but they are organic compounds. So for example, we know about acetone, the one that's from the nail polish that we use. Sometimes it's a mixture. They want to save and they want to make it less volatile because acetone is very volatile. So we know acetone, we have acetic acid, kana sa suka, formaldehyde, kana sa mga formalin, no? Ether, kana sa mga surgical equipments, they sterilize it with ether. And also solvent in the lab. We have the isopropyl alcohol, the one that we always see in the kanang mga kuan ninyo, pang hunaw sa kamot, no? Especially when you enter the malls, everywhere you see they sometimes they use isopropyl alcohol, but they also use methanol or methyl alcohol. So many others. So there are common names that we already encounter. But memorizing, of course, a large number of organic compounds can be very tedious. So that's why the International Union of Pure and Applied Chemistry, or what we call as AUPAC, established a systematic way to provide us on how to name organic compounds. So the basic rules on the nomenclature. Nomenclature is simply naming of organic compounds. We start with hydrocarbons. So what are hydrocarbons? They're simply you've learned that in your lecture, no? They are simply organic compounds that only contains your hydrogen and carbons. Okay. And of course, you will have, there are three kinds of hydrocarbons. That's what you've learned in the lab. One is the alkane. You have when you only see a single bond between carbon-carbon, you can also see alkene. When you see a double bond, and alkyne, you see triple bond. So there are other organic compounds as well that we will learn. I think it will be in activity 3 or 4. Okay, but for now, we will start studying the how to name hydrocarbons. So for other class of organic compounds containing other functional groups, no, we'll set aside for that in other activity. So you will name organic compounds, particularly the hydrocarbons by the UPAC system. And from the name, you should also be able to write the structures of organic compounds. In activity 1, you learned how to write the structures of organic compounds using the Lewis structure, where you show all the carbon, hydrogen, atom-atom bonds. Now you show all the covalent bonds as well as the unshared electrons. You've also learned in activity 1 how to write the organic structure using the condensed formula and also using the zigzag formula. So I think now that you are familiar with writing the structures of organic compounds, now we will review again how you are able to write the structures of organic compounds based from the names. So first study on how to name hydrocarbons, and then after that, when you know how to name from the name itself, you can also determine the structure of the organic compounds. It will be very important, particularly in higher later, when we are looking into reactions. So in naming the organic compounds, you've learned that in organic in your lecture, that the reason why we give a special attention to the element carbon and make a special how do you say component in chemistry called organic chemistry It's because of the element carbon can form multiple bonds, no, in a sequence of carbon-carbon change. It can even branch now to a large carbon-carbon branch is the backbone. So when we name, we always select the continuous chain of carbon compounds. So for example, we have this structure, you have the structure, and you have 1, 2, 3, 4, 5, 6, 7, 8, 9 straight chain. And kung maliko ta, this is what we call as branching, the one that deviates from the kind of continuous carbon chain. We call this one as branching. So you count 1, 2, 3, 4, 5, 1, 2, 3, 4. On carbon 4, if we start counting from the left, there is what you call as branching here. So if we continuously count from the left, you have 1, 2, 3, 4, 5, 6. So there are 6 straight carbon chain. If you start counting from the left, you start counting from the right, you have 1, 2, 3, 4, 5, 6, 7. Okay, so the question now is, which direction did you count where you have the longest continuous carbon chain? Is it the straight, kaning branching sa left, or kaning pa-branching kaning sa right? No, you have 9 here, 3, 4, 5, 6, 7, 8, 9. And you have 3, 4, 5, 6, 6 kani siyang counting, or 7 sa isa. And you can see that the longest continuous carbon chain is kaning first one, kaning I. Okay, and because of that, we can name our organic compound, this hydrocarbon, based on the longest continuous carbon chains. And since there is 9, now there is a root table on how we name our alkane based from the number of carbons. So if there are 1 carbon atom in the continuous carbon chain, then we name our generic root to be met. If there's 2, it's F. If it's 3, it's prop. 4, but. 5, pent. 6, hex. 7, hep. 8, oct. 9, non, and 10, dec. Okay, so since earlier, there are 9 continuous carbon chains, so our generic root should have been non. And since it is an alkane, then our suffix, the one that will be included after our generic root, should end with ane. If we only see all single bonds, that's all for alkane, where you have this general formula, then how we name organic compound should end with ane. If, however, we see a double bond with the longest continuous carbon chain, the name of the organic compound will end with ene, or ene. If we see a triple bond, this formula, then we see we should name our organic compound or hydrocarbon that ends with yne, or e, or ine. Okay, so the parent chain beginning at the end, which gives the lowest possible number to one of the following. So we should give the order according to the priority. You have the double bond, the triple bond, and the substituent in the absence of multiple bond. So first, we gave the longest continuous carbon chain earlier. Wala gihatag, no, but the longest continuous carbon chain earlier is you have 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7, 8 to the I. So that should be octane, because 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. So there is this 6, and there is this 7, and there is the straight chain that is oct, no? So therefore, we select the longest continuous carbon chain that should have been oct. So our longest continuous carbon chain in the example is I. So we should name it for 1, we should name it as, copy this. Okay, loading. So you should name it with octane, no? So Our next thing then is to determine what is this branching all about. So we have already named the straight continuous carbon chain, but also in the name, we have to include the one that is not included in the continuous carbon chain. So the one, this atoms that are not group of atoms that's not included in the continuous carbon chain, we will call them as our substituent. Okay. We call that one as our substituent. So the substituents are a group of atoms that are not included in our continuous carbon chain. So our substituents can be alkyl, or can be other atoms. So the usual alkyl substituents can also be named based from its carbon number. So we have the methyl. Now, methyl is just a methane with one carbon atom. No, in a complete methane is when you have one carbon atom with all four hydrogens in it, but minus the hydrogen, you have the CH3. You call this one methyl. No, it's a substituent. It's not included in the straight chain. So you add with Y or E. If you have two carbons from the word ethane, no, minus isa ka hydrogen, you call this one as CH3, CH2. Okay, you have CH3, CH2, CH3, CH3 dapat si ethane, minus the hydrogen, you have the ethyl. Propane, your substituent will become propyl minus one hydrogen. Butane, your substituent become butyl minus one hydrogen, and pentyl with 5 carbon atoms minus one hydrogen. So let's look at our example earlier. Okay, or here you have your continuous carbon chain. Okay. So this becomes your parent chain. So our parent chain contains 8 carbons, no? So it's, you have to remember, so 8 carbons, 8 straight carbons. So there are 8. There are 8 continuous So therefore, our parent chain, we call this one. Our parent chain we call as octane. Okay, so you have the oct, and that's our suffix, generic root, and then we end with ane, or we name this one as octane. Okay. So we have already named this. Okay, but we haven't still figured out what is this one. So this one already becomes our, okay, this becomes our substituent. Okay, our substituent is the group of atoms that's not included in our parent chain. So this one kaning sa box mo ni atong parent chain. Okay, so our substituents is an alkyl. No, alkyl just simply contains carbon and hydrogen also. And you see that there are 2 carbon atoms minus isa ka hydrogen sa CH3 parehas sa ethane. So name this one as ang substituent na to. We name this one as ethyl, CH2, CH3. Okay, minus the hydrogen. So you have the ethyl substituent. Okay, so how do we include the ethyl substituent? Now we need to know where is our substituent ethyl located is. So in our name, okay, the location comes from, if you start counting from the left, the location of your ethyl is on carbon 4, but if you start counting from the right, okay, you'll be 1, 2, 3, 4, 5, ika 5. So therefore, if we choose the location, or we call that one locant, so 4 and 5, we choose the one with a lower locant. Okay, so therefore your ethyl is located on carbon 4. So indicate that ethyl, Canisian substituent, is located on carbon 4. So we include this to be 4. This one is located in carbon 4. Okay, you can start counting, as I mentioned earlier, you can start counting here from the left. That's carbon 1. Okay, that's carbon 1, carbon 2, carbon 3, carbon 4. If you start counting here, this becomes carbon 1, carbon 2, carbon 3, carbon 4, and carbon 5. So we don't choose carbon 5, but instead we choose carbon 4 location. We choose the lower location of the substituent. So therefore, we name this one as 4-ethyl substituent. Now, how we do the name, the complete name. So for the name, we will have the parent chain, no? When you do the name, you have the parent chain, and before the parent chain, we actually have our substituent plus the parent chain. Okay, so our parent chain is octane, right? Our parent chain is octane. So before the parent chain octane is our substituent, just like how you name your first name and last name. So even if you alphabetize, you always start with the last name, right? And then saka na yung first name. So, but when we do the organic compounds or the hydrocarbons, of course, or any organic compounds, our last name will always be the parent chain. Our substituent is like our first name. So our substituent is 4-ethyl 4-ethyl octane. So i-continue rin mo siya. So that will be the name of our organic compound. So the following are the rules for punctuations. Now we use a dash to separate a number from words. So that's why I use a dash and a comma if we use to separate numbers. So we can also use die, try, tetra when there are many. So for example, you have this structure. And the first step again to name is to find the longest continuous carbon chain. Okay, so you have here, you can count starting from the left. You have 1, 2, 3, 4, 5, 6, 7. Of course, you can also divert your counting depending on asang longest continuous carbon chain. So, timing the way that the longest continuous carbon chain is straight lang po. Okay, but pwede po na siya munaog ta if we foresee that one is the longest continuous carbon chain. So this one is a straight. So straight, ang longest continuous chain is located siya sa straight manner as we saw the structure. So in this case, our longest continuous carbon chain is our parent chain. Our parent chain is pila ka carbon? Pila ka carbon na tong parent chain? Anyone? Are you with me? Pila? Pila? 7. Okay, so pag 7, what is our generic root pag 7?
Hep.
Okay, so since it's 7, so our generic root should be hep. And since these are all single bonds, so we end with ane. Okay, so you have your ane, and you have your okay, we end with ane. Now let's look at the other atoms. So you have here CH3, CH3, CH3. These are what we call as substituents. Okay, so our substituents are actually, tawag natin yung 1 carbon atom minus the hydrogen. We call this one as our alkyl, no, substituents. And we call that one to be, isa lang man ka-carbon. So we call that one to be methyl. So our methyl is located, if you start counting from the left, our methyl is located on, natay sa carbon 2, no? Pila ka bok sa carbon 2, pila ka methyl?
Duha.
Okay, so aha man siya located, na siya sa carbon 2, so we include 2, 2, comma, okay, and another on carbon 4, so include 4, and another on carbon 5, so we include 5. Okay, should have been dash methyl. But then again, since there are 4 methyl groups, no, we include a prefix methyl. So we have tetra methyl. Okay. You have, so alternately, you can also start counting from the right. Okay. So if you start counting from the right, let's see. Ano yung itsura? Or how do we indicate the location? Kaning mga, by the way, kani siya, kung mention ka tong location, no? We also call that one to be kani locant. Tawag natin siya locant or location that will indicate the location of our substituent. Locant. Okay, so we can also start counting from the right. So if you start counting from the right, okay, you have carbon 1. Here, carbon 1, it will be carbon 1, carbon 2, carbon 3, carbon 4, 5, you have 6, and then you have carbon 7, kanisha. No, so if we have this manner, then we start counting our locant to be 3, our methyl to be on, if you start counting from the right, we'll have our methyl, okay, and the location of the methyl is on at carbon 3. You have on carbon 4, tanawa in green. You have on carbon kani. This is 4, 5, 6. Okay, on carbon 6, 6, 6. And then there are 4 tetra methyl. Now you notice if we compare, no, there is already a point of difference. Now we always choose the first point of difference na lower ang location sa locant. So between 2, 2, 4, 5 tetramethyl or 3, 4, 6 tetramethyl, we choose this one. Okay, we choose this one because there is this lower location of the locant. Okay, so now when we name our alkene, okay, we name as, so the name is, you have the heptane, and then before the heptane is our substituents, right? Remember, when we name, you always have the you always have your, so ito, pairing chain, right? Before the pairing chain is your substituent. So we name, so in our case, our pairing chain is heptane. And before the parent chain, you have the 2,2. You have the methyl, right? And methyl, there is this location on 2, 2, 4, 5. But since that is 4, so we include tetra dash to separate the number and letters. You have dash, and then since there are 4, you have tetra methyl heptane. Okay, so this is our name for this organic compound. Now, just if in case gani that our Zoom is cut, no, just click again on the link so we can start our meeting again. Okay, so that is how we name. We choose the lower locant. So going back to our discussion, so that's how we name. Sometimes there are other substituents I just have to familiarize. For example, now when you are having three carbon atom, you should name that one as propyl rather for the alkyl. If the connection or the bond to the main parent chain is on the terminal carbon, and we call it propyl, right? But if it's in the second carbon atom, the connection or the covalent bond to be connected to the parent chain is on the second carbon atom sa propyl, 1, 2, 3 carbon. We call it one as isopropyl. Sa butyl, if it's not on the terminal carbon, the connection or the bond to be connected to the parent chain is the second carbon. Then you have secondary butyl. It can have third butyl. There are 3 carbon atoms, and on this central carbon atom having methyl groups, it calls this one as third butyl. And isobutyl, you have this kind of structure. You have CH3, CH3, and then you have this. Of course, there's also the IUPAC name, but it's you just have to memorize this isopropyl, secondary butyl, isobutyl, third butyl, or T-butyl. That's a common name for our alkyl group, so it's acceptable in the nomenclature of organic compounds. Okay, so it's very simple. So sometimes our substituents can also be halides. So what are those halides? Halides are the one located in the group 7 in the periodic table. So if we ever see our halogens, then we call the substituents not as fluorine, no, but fluoro. You end with O, fluoro, chloro, bromo, iodo. That's how we name our substituents. Okay. Now again, if we see a double bond or a triple bond, now we always we name our alkane or our hydrocarbon rather to end with we end with ENE pag na double bond. For example, propene or 1, 2, 3, or YNE when there is a triple bond. No. But when there is a double or a triple bond, we have to indicate where is the double bond or the triple bond is located. So again, we always have to name for the longest continuous carbon chain containing your double or your triple bond. Okay, so in this case, you have 1, 2, 3, 4, 5, 6, 7. No, here is an example. And of course, again, you can start counting from the left or you can start counting from the right. So this one, there is a straight carbon chain. And there are 7 carbons. So pag 7, we start with hep. Okay. Hep. And then since there is a double bond, then we have our ending that not A-N-E, but E-N-E. So our parent chain is heptene, no? And we need to know where is this in located. We need to know where is this in located. So therefore, we need to have the location of our locant. And the double bond is located on carbon. It's on carbon 2, not carbon 3. So we can start counting actually from the left, like 1, 2, 3, 4, 5, 6, 7. If you start counting from the left, the double bond will be on carbon 5. We only indicate the carbon atom that first carbon atom that contains the double bond. So from the left, it's located on carbon 5. If you start counting from the left, it's located on carbon 2. So the name of this is 2. We name this one as 2-heptene. Okay. Okay, sometimes if we see the triple bond as I mentioned, so you name the same manner. So you count 1, 2, 3, 4, 5. You start count from the left, from the right. So it should be pent. You should name it as pent. And since you have a triple bond, then you end with Y in E. Okay. And of course, we have to know where is the Y in E located, or the triple bond. It's located on, if you start counting from the left, it's located on carbon 2. If you start counting from the right, it's located on carbon 3. So we choose the one that is of the lowest locant. Okay. And sometimes you can see a double or triple bond in the same the same structure. No? So if we have that one, if both the double and triple bonds are found in the parent chain, the double bond gets higher priority in numbering, lower the suffix is located before that. When we have this, our parent chain will always go for the one the higher with the triple bond, not the double bond. Okay, so that's why you have the Y in E. And the double bond, so the double bond gets higher priority in numbering, lower number, and its suffix is indicated before the triple bond. So that's why you have 2-hexene, hex, and 4 Y in E. Okay, the last one is the Y in E, or the E. And again, we have to indicate where is the double and the triple bond located. So from the left, start counting from the left, our in, it's located on carbon 2. Okay, and our Y in E is located on carbon 4. And of course, our generic root having 6 carbons start with hex. Again, as I mentioned earlier, all groups not included in the parent chain are considered as substituents. Okay, that's how very simple we can name our organic compounds. Okay, let's start this one. We can start naming this one. So say as an example, let's say, how do we name?